Okay. Um, I think we are live.
Okay.
Yeah. Okay. So, hi everyone. Um, my name is Manu Quadros. I'm a PhD student in linguistics at Yale University. And today I'll be moderating Professor Jackendoff's talk. This talk is part of Abralinha ao Vivo Linguists Online, an event organized by the Brazilian Linguistics Association in partnership with several international organizations, including the Permanent International Committee of Linguists, the Association of Latin American Linguistics and Philology, the Argentinian Linguistic Society, the Spanish Linguistic Society, the Linguistic Society of America, the Linguistics Association of Great Britain, the Australian Linguistics Society, and the British Association for Applied Linguistics. It's a great honor to introduce Professor Jackendoff, who hardly needs an introduction. When I began studying morphology still as an undergrad, I learned to pay special attention to the ramifications of three classics that came out shortly of Chomsky's remarks on nominalization, like Mark Aronoff's work, Maurice Halley's work, and Ray Jackendoff's work. Well, it turns out that Professor Jackendoff studied under Noam Chomsky and Maurice Halley, earned his PhD in linguistics in 1969, and went on to become one of the central figures, not only in the study of morphology, but also of conceptual semantics and syntax. All of these fields are brought together along with phonology in his parallel architecture. At present, Ray Jackendoff is Emeritus Professor and Co-Director of the Center for Cognitive Studies at Tufts University. His talk today will be called The Texture of the Lexicon, Relational Morphology in the Parallel Architecture, which is also the title of his most recent book, written with Professor Jenny Odring, where they explore the place of morphology in the parallel architecture. So without further ado, thank you so much, Professor Jackendoff, for giving this talk. It's a great pleasure to invite you to our virtual stage.
Thank you. There we are. Thank you for this invitation. It's an honor to speak in this huge series of events that you've created. And hello to everybody who's watching. I guess I want to share my screen, don't I? There we are. Okay. Over the past 50 years, it's hard to believe it's 50 years, but it is 50 years that I've been doing this stuff. Over at least the last half of it, I've been trying to develop a unified theory of knowledge of language. I want syntax and semantics and phonology to interact properly, and I want them all to fit into a theory of language processing and language acquisition. And I want language as a whole to fit into the rest of the mind so that it interacts properly with other mental capacities. This is really ambitious, of course, but I think we're making some progress over the years. Whoops, this is not moving. Is there a reason?
If you click on the PowerPoint and then use the arrows in your keyboard, it's going to work.
What I was doing. There we go. All right, let's keep going. So I've worked out, as you heard, I've worked out the overall position called the parallel architecture. Most of that work is based on the relation of syntax and semantics. And this is laid out in my book, Foundations of Language. And the syntactic part of it goes into great detail in a book called Simpler Syntax, which I wrote with Peter Culicover. The recent work has been a collaboration with Jenny Odring, who works in the Netherlands in Leiden. We started a few years ago by trying to extend the parallel architecture theory into morphology, but it turned out to have larger consequences, and I'll try to talk about some of these today. The work has developed into a book that came out this past February, which we call Relational Morphology. We think it's kind of a breakthrough, not only in morphology, but also potentially in syntax, the theory of the lexicon, and even linguistic theory as a whole. I guess I should tell you to go out and buy it right now, right? Anyway, today I want to sketch some aspects of the approach without getting too technical. Here's what I'm hoping to cover. First, relational morphology's conception of the lexicon and the grammar. That's the basis for everything else. How the RM formalism deals with some interesting cases of lexical relations. And I'll talk briefly about extending this formalism to syntax, and even more briefly about how we extend this view of the lexicon to other cognitive domains. And I'm hoping to show you in the course of it a bit of how RM moves towards the goal of unifying linguistic theory, because it enables us to eliminate the distinction between core and periphery. It enables us to at least integrate the distinction between productive and non-productive patterns. It allows us to integrate the relation between morphology and syntax. It allows us to plop the grammar right into a theory of language processing. I won't be able to talk about that today. And it gives us some at least intriguing prospects for integrating language with the rest of the mind. An important part of the approach is that we take a very hard line on mentalism. We take Chomsky's term knowledge of language very seriously, sort of psycholinguistically, I think more so than in standard linguistic theory. If we reformulate the basic questions of linguistic theory in psycholinguistic terms, they amount to this. First, what linguistic elements does a speaker store in memory, and in what form are those elements stored? Second, how are these elements combined online to create novel utterances? And third, how are these elements acquired, and what does it take in the language learner in order for acquisition to take place? Now, the central concern of generative grammar from the very beginning, syntactic structures and before that LSLT, the concern has been the creation of novel utterances. And I want to take issue with this as the primary focus. Along with construction grammar and other constructionist schools of thought, we question the traditional sharp distinction between the lexicon and the grammar, as though these are two entirely separate aspects of the finite means. So, traditionally, if you get a dictionary of the language, the grammar is at the last 10 pages or something. We want to say they should be integrated. The lexicon is usually viewed as not very interesting. It's just a list, something for lexicographers. Shalom put it. Domain of the lawless. But this means that lexicon isn't very interesting. It's just a list. And the main concern is with the rules of grammar, which are supposed to be building novel structures out of lexical items. And of course, rules have to be stored in some form too. So we're going to ask, how are rules stored? We think that they're stored in the same format. And here's where morphology comes in. Morphology is the grammar of words. Syntax is full of regularity and it's easy to create new forms, but morphological phenomena hit you in the face with their idiosyncrasy. There are lots of morphologically complex words that can't be built directly from smaller pieces. They have to be stored. I'll be showing you a lot of those. And psycholinguistic experiments seem to show that morphological complexity plays a role in language processing. So it looks like morphologically complex items have to be stored with their internal structure. And it has to be concerned not just with the active generation of novel forms, but also with codifying the structure of words that are stored in memory and the properties that they share with other words. In order to show you how we conceive of morphology, first I need to review a bit about the parallel architecture framework. The most basic idea is that linguistic structure isn't determined entirely by syntax, as it always has been in standard generative grammar. So semantics and phonology are treated as, quote, interpretive, whatever that means. Rather, on the parallel architecture view, linguistic structure is determined by independent generative systems for phonology, syntax, and semantics, and crucially, the linkages or interfaces between them. So the idea is that the well-formed sentence is not just generated out of the syntax, it has well-formed structures in each domain, plus well-formed links among the structures. And there are similar linkages to other mental representations. So think about how we talk about what we see. There has to be an informational conduit between high-level visual representations, whatever they are, and linguistic meaning. You can't derive visual representation from language, and you can't derive language from visual representation. So what makes a lot more sense is a system of correspondences between the two, which is what the parallel architecture is advocating inside the language capacity as well. So in comparison, a traditional derivational approach to grammar gives us no purchase at all on the language vision, on the relation between language and vision. Well, you'll notice there's no lexical component in this diagram. So let's see what a word looks like in this framework. So it has a piece of semantics that I'm just coding as capital Pig, a piece of syntax, that's it's part of speech, and if you're in a gendered language, it has a gender, and maybe number, and it's phonology, how it's pronounced, in this case, pig. And there, instead of enclosing the three components in large square brackets, as is customary in, say, HPSG, we're using co-indexation. Co-index 1, for example, well, that's the only one there is. Co-index 1 here indicates the interface links between the three components. So we're regarding a word as part of the interface. It's a well-formed piece of phonology linked to a well-formed piece of meaning and to a collection of syntactic features. And you can think of this entering into a processing model. It's as if you're hearing language and you hear the pronunciation pig, you're entitled to add a noun, a corresponding noun in the syntactic structure you're building in working memory, and adding the semantics of pig into the conceptual structure you're building in working memory. If you are producing language, you start with the idea of a pig, and that entitles you to put a noun in your syntax and pig in your phonology. So we see that there's sort of a direct use of these interfaces in processing, for example. This is really kind of boring. It gets more interesting when we look at a morphologically complex word like piggish. So here it is. This shows the internal structure of piggish and its relation to its base. So to make it a little easier to understand what's going on, I color-coded it. Here we go. First of all, the whole thing, the semantics means it means a property of being like a pig, and in particular being sloppy. In the morphosyntax, it says this is an adjective that is built out of a noun and a suffix and an affix. In the phonology, it's pronounced the way that noun is pronounced, pig, followed by ish, which is part of the affix. So here, co-index 2 is notating interface links. There's a 2 that's hidden in the corner there, subscript on like pig sloppy. But this indicates what's co-indexed in green. It's the whole word piggish and its morphosyntax and its phonology. And the co-index 2 functions like the co-index 1 in pig. In blue, we see the components of the suffix, its meaning that it's a function that says like something, and it's an affix in morphosyntax and it's pronounced ish in phonology. And these are linked together by interface link 3. Finally, co-index 1 not only ties pig together, it also ties together the elements of the base of piggish. And also by virtue of their both being subscripted 1, they're related to each other. And we'll call this a relational link. So a relational link is specifying that 2 linked units have the same structure. So you can, what do these co-indices mean? Well, you can think of the co-indexation as marking the ends of association lines, as in this diagram. So the black lines are interface links that give you relations between different levels of the same item. And the red lines, the red arrows, are indicating relational links that give you the relation that say 2 parts at the same level of different items are the same. You could use this as your standard notation, but it would get really sloppy in quite a hurry. So we stick with the co-indexation. But keep in mind that that's what it means. Notice that sloppy in the semantics isn't linked to anything. This is an idiosyncratic part of the word meaning. And it tells you not only that piggish means like a pig, but like a pig specifically in sloppiness, not say in pinkness. Now, in the case of pig and piggish, the relation between the whole word piggish and its base, pig, is 1-to-1. So for each part in phonology, there's a part in syntax and a part in semantics, and vice versa. But of course, this being morphology, this isn't always the case. Think about the plural sheep, which is on the right here. It has a plural feature in its morphosyntax so that you can determine agreement. You can say these sheep are, as opposed to this sheep is for the singular. But there's nothing that maps into there's no component of the plural sheep that maps into the phonology. The phonology is co-index 4 with the singular sheep, and it's co-index 7 with the entire word. So we get the effect of a zero morpheme without positing a morpheme. It's zero because it isn't attached to anything. It's not expressed in the phonology. And of course, there are lots of cases like this in morphology. So the next thing we want to do is express the parallelism among all the ish words like piggish, childish, foolish, thuggish, and so on. So to do this, we introduce a schema for ish. It has variables on all 3 levels. It says, if you want to talk about a property of being like something, that's the variable x in the semantics. You can do so with an adjective that's in the morphosyntax. It's made up of a noun that means x because it's co-indexed. That means x plus an affix, and it's pronounced however the noun is pronounced. That's the phonological variable, and it's followed by ish. In the schema, the variables are linked by variable co-indices. So variable co-index y connects the 3 levels of the whole schema. That's on the outside in green. And variable co-index x connects the levels of the base. That's in red. The idea behind variable indices is that the variables can be instantiated by anything with the same pattern of links. So the schema is functioning very much like construction grammar's construction. So here we see the schema and 2 of its instances, piggish and childish. Co-index 3 is a constant. It says the affix is pronounced as ish and has the same meaning in all 3. That's in blue. The variable index x is realized as 1 in piggish and as 8 in childish. That's in red. Co-index y, co-index y, which is linking the whole word together, is realized as 2 in piggish and 9 in childish, and that's shown in green. So I hope that is fairly clear because we'll be doing much more of it as we go along. I hope you'll catch on. Now, what I want you to notice, by the way, is that sloppy and silly are not connected to anything. These, again, are in idiosyncratic parts of the word meaning that are not covered by the schema. Where do all these morphological schemas belong? And our idea is that instead of the traditional 4 domains, phonology, morphology, syntax, and semantics, plus maybe phonetics on this side and pragmatics on this side. Oh, you can't see my hands. Whatever. We want to think of morphology as the grammar of words. So like phrasal grammar, it involves phonology, syntax, and semantics, but this time below the word level. So relational morphology is concerned with the structure of morphosyntax, plus its interfaces to phrasal syntax and to the phonology and semantics of words. Those are the components shown in red. This is not a brand new idea. It was proposed actually by Emmen Bach in 1983 in the very first issue of NLLT. And it's since been proposed again by Harry van der Hulst and by Ackerman Neleman. I don't think it's caught on very much with the community as a whole, but I think it's the right idea. It says there's a continuity between morphosyntax and phrasal syntax, but we can still preserve the differences. So morphosyntax doesn't reduce to some form of phrasal syntax as it does in, say, distributed morphology, but it's also not entirely distinct from syntax as it is in, say, paradigm function morphology. And as we've seen with the ish schema, morphology is not a matter of rules building words procedurally. So the standard way of thinking about morphology is with morpheme structure rules that say Things like to form the English plural, add an S to the singular. We're giving that up. And a variety of theories on the market state the grammar in terms of constraints or templates or schemas instead of derivations. So there's no input or output. And this is not just the parallel architecture, but also LFG, HPSG, and especially construction grammar and construction morphology. Now, this schema that I've written for ish could be thought of as a notational variant of traditional rules. So a traditional rule would say to form an adjective from a noun, add ish. How's the schema different? Why should we prefer schemas over our old friends' rules? Well, here are some differences. First of all, that schemas are in the very same format as words. They're pieces of linguistic structure that are linked by indices. They're not something entirely different. A piece of stored structure is more word-like if it's completely filled out with constants like pig is. It's more rule-like if it's got variables like the ish schema. So we don't need to have separate constructs of lexicon and grammar. We can think of the rules of grammar, the so-called rules of grammar, entering into what you might call an extended lexicon that includes both the words and the schemas. In addition, once we have that idea, we can now restate phrase structure rules in this format. So we can say the verb phrase, transfer verb phrase rule is not expand the verb phrase into a verb plus a noun phrase. Rather, it's a verb phrase can be composed of a verb plus a noun phrase. So it's a piece of structure we have to build sentences with. This is the kind of primitive they have in tree adjoining grammar, what Janet Fodor calls a tree list. What's interesting about it from a construction grammar point of view is that it has only one component, syntactic schema. It doesn't have intrinsic interface links to phonology or to semantics. This is a little different than the construction grammar take on things. Now I want to look at another difference between schemas and rules. It's a way in which schemas are more flexible. Let's think about this VP schema again, which says a verb is followed by an object. A rule, if it's stated as a rule, it's supposed to be the source of creative combinatoriality. So a rule like this combines items that are stored in the lexicon, and its output is a structure that is not in the lexicon. Now, this is a problem with idioms, let's say, that have verb phrase structure like spill the beans or shoot the breeze or kick the bucket. They look like verb phrases. They have standard old-fashioned syntactic structure. So if we want to capture this generalization, we have to generate them by a rule. But you can't generate them by a rule because their meaning is wrong. So you have to store the idioms. You can't generate them. So it looks like you need to have it both ways. This is not so good. There are plenty of cases like this in morphology, patterns that you can't generate for one reason or another. So first of all, let's look at words that have partly compositional semantics. Let's take a word like football. It is follows the compound rule. It's two nouns forming a noun. The second one is the head. And its meaning is it's a kind of ball that has something to do with your feet. But it has lots and lots and lots of semantics that goes beyond that. All your knowledge of footballs and its role in the game football and so on and so forth. And those can't be derived from the compound rule. Rather, you have to list everything you know about football in the lexicon or your world knowledge or something. And so the rules can't do it. But if you have a compound schema that says, here's some of the elements that go into forming compounds, but you're welcome to add all kinds of idiosyncratic information, then we're cool using schemas. Another kind of case is the irregular phonological alternations from the good old past tense project that went on, the dispute that went on for a long time in the last decade. So take this alternation of sing and sang. There's about, I don't know, a dozen verbs that have this alternation. But then there are others that have a different alternation. It's not sting, stang, but sting, stung. And there's about a dozen verbs that have that kind of alternation. there can't be a regular rule that distinguishes one alternation from the other. And in addition, there's think, thought, and bring, brought, and also clinked and blinked. So you have to know which verbs go with which regularity. Again, you can do this with schemas. You can't do this with rules. But if you list them, you have to list them, but that means you can't generate them by the rules. Another case is words that have predictable phonology and meaning. Everything is okay there, but you still have to list their existence. So an example is the verbs formed on adjectives by adding en. So widen and stiffen and blacken and roughen and harden. It looks perfectly regular, but in fact it cannot apply to every candidate adjective, right? You can't have louden, you can't have safen, you can't have crispen. Those should fit, but they don't. So what you have to do is list which ones undergo the rule. That means that you are, in effect, the rule isn't doing its work anymore. Fourth case, I think, is the strongest one. There are lots and lots and lots of words that have an identifiable affix, but a non-lexical base. So think of commotion. The shun is our good old friend, the shun suffix that makes nominals out of verbs, but there's no verb commote that commotion can be made out of. Or impetuous. There are lots of OUS words like glorious and joyous and so on. And so this is an example of those, but there's no verb impet or impetu or something like that this is derived from. So we can't use rules to generate these words. So a summary is that standard rules overgenerate. So any rule that gives you widen will also give you louden, but they also undergenerate. So they don't give you all the semantics of football, and they don't give you the base of impetuous, which doesn't exist in the lexicon. There's nothing to go for. So the widely adopted solution to these problems is the lexicalist hypothesis of Chomsky 1970 remarks on nominalization. The lexicalist hypothesis, basically, as it came to be understood, it's not exactly what Chomsky said, is that regular and predictable patterns belong to syntax. Idiosyncratic patterns belong to something like lexical rules or lexical redundancy rules. These are rules in the lexicon, whatever that means. And the idea is that if an item shows any amount of idiosyncrasy, it's in the lexicon, it's not generated by the grammar. So the effect is to remove from syntax all traces of the impure. You might think of it as grammatical apartheid. Even so, how do you generate spill the beans? Its syntactic structure is perfectly in tune with the verb phrase rule, but the verb phrase rule can't generate it because it's in the lexicon. So we might say, well, there's a lexical rule that generates verb phrases as well that we just use for idioms. But do we want the very same rule in the lexicon and the grammar? That seems kind of weird. We'll be coming back to this point in a while. But with this in mind, we can see a second important difference between schemas and rules. And I think this is one of the innovations in the relational morphology approach. Schemas can play two roles in the grammar. The first one is generative. You're using schemas to build up novel composite expressions by unifying the schema's variables with other material. And this is just like traditional rules. It's procedural. It becomes procedural. Of course, the schemas are declarative, but we make it procedural. The putting together of pieces is actually carried out from a procedure called unification, which is used in LFG and HBSG and construction grammar, that actively assembles pieces into larger structures. So unification is performing the function that merge does in the minimalist program, and it's somewhat different, somewhat more powerful than merge, but I think it's justifiable. I don't have time to take on that issue here. Just have to trust me. The second role is what we'll call relational. And here a schema captures generalizations among items stored in the lexicon. So it's capturing, the way it captures these generalizations has been called motivation and inheritance, or our friends' lexical redundancy rules. So in this role, in the relational role, a schema doesn't have to exhaustively specify the contents of the items that are being related, such as the sloppy and piggish and the silly and childish. And schemas can function in both of these roles at once. So let's take our regular plural schema, which applies all across the board in English. But there's also stored regular plurals in things like raining cats and dogs and make amends and odds and ends and shake hands. That's a plain ordinary plural. But of course, again, we can't generate these from by rule because they have to be stored in the lexicon. They're idioms. So the idea is that these are accounted for relationally. It's still the same schema for the regular plural, the same regularity, but it's realized this time in the relational role rather than the generative one. And this conclusion is kind of amplified by a lot of psycholinguistic research. I'm thinking of work by Bayan and Schroeder and Allegra and Gordon and so on, where they find that lots of completely regular forms like shoes and eyes, which are more frequent than their singulars, turn out to be stored rather than generated online. And again, so for these cases, we'll be using the regular plural schema, but in its relational role. And again, even the frequent shoes turns up in collocations like tie your shoes, wipe your shoes, shine your shoes. So we're back in the same world again. The schema can account for it. Getting it by a regular rule is a little more difficult. Another example of the two uses of schemas is compounding. It's certainly productive. There are lots and lots of novel instances. You encounter new compounds all the time. But of course, there are also thousands of lexicalized compounds that conform to the compound schema. So this solves the problem of rules undergenerating, as we saw in football. And because the relational role doesn't require you to predict everything about every instance. How do you stop schemas from generating too much? Well, the answer is that some schemas don't function generatively. They only function in the relational role. So let's go back to our harden, darken, widen, stiffen, loosen, but not safe and louden. The schema is perfectly regular in its semantics. It says it means become hard or cause to become hard, cause to become dark, and so on. But you have to learn which, and it's perfectly regular in its semantics, but you have to learn which possible instances are actually words. And you also have to learn idiosyncrasies of individual instances. So you have lengthen and strengthen rather than longen and strongen. And you have embolden, which has a prefix that also means cause to become. And it appears by itself in things like enslave and embitter. So the idea is that this schema only functions in the relational role to draw the generalization among the instances that are also listed. So the patterns for which a productive rule would overgenerate are captured by a non-productive schema. And in fact, the bulk of morphological patterns, at least in English, involve non-productive schemas. Well, you might say this is all well and good for morphology, but syntax is different. But as I mentioned a minute ago, idioms have been a problem for generative grammar because they have to be listed in the lexicon to account for their idiosyncrasy. But at the same time, most of them have structure that looks like it's generated by the rules from smaller pieces. If we recognize the relational function of schemas in addition to their generative role, we can break the logjam. So the productive verb phrase schema is used generatively in a novel instance like eat the spider, but it's used relationally in an idiom like chew the fat, which is listed in the lexicon. Again, it's the same schema, just used differently. Well, you might say these non-productive schemas are all well and good in morphology, but syntax is different. It's all productive. Not true. If you poke around the corners of English syntax anyway, you find some non-productive schemas. So one of them is this NPN construction that you get in day after day, week by week, face to face. If you ask what prepositions can go in there, you find there are 5 after, by, to, for, and on or upon. But you don't get things like gun beside gun when you had a lot of guns lined up. You don't get doll in doll when you are talking about Russian dolls, let's say nesting Russian dolls. So you have to learn which prepositions are good there. That's so that this is now a non-productive schema. at least on the prepositions. The choice of noun is productive. Another case is this little determiner construction that you see in what a job, such a job, many a job, hardly a job, where the elements that can go in that position have to be learned individually. You don't get who a professor or where a city. I'm not even sure what those would mean. So again, you have to list the instances of this construction and learn them one by one. So the question arises, there's a logical possibility. We have schemas that are used generatively and relationally. We have schemas that are used only relationally. Are there schemas that are only used generatively? And the answer is no. Notice that schemas that are only used generatively would be our standard rules of syntax, let's say, that are only used to put things together. But there cannot be such schemas because you can always memorize new words and phrases and idioms or other pieces of structure. And when you do, when these pieces are in memory, they're supported relationally. They're not necessarily generated on the fly anymore. So we end up with two kinds of schemas. The first kind is productive or open schemas, which both generate new expressions and motivate stored items, and non-productive or closed schemas that just motivate stored items. So the conclusion is that we are negotiating the border between core phenomena, the big productive syntactic rules, and the periphery, the little restricted syntactic rules. Both of them are encountered in terms of schemas. What we get for this perspective is that all schemas can be used in a relational role. The productive schemas are just like the non-productive ones, except that the productive ones also allow free online composition. So we can think of productive schemas as ordinary schemas that have, so to speak, gone viral. Maybe that's not a good expression these days. Anyway, they're a special subset of the larger class of linguistic patterns. This leads to a methodological conclusion, which is that the relationships among items in the lexicon ought to be an important focus of research, not something we just throw away as junk, because the relationships in the lexicon include all the generative rules. This leads to a conclusion for the interim, where we're taking stock on where we've gotten so far. And I think it goes like this, that Humboldt's infinite use of finite means is only a part of the picture of what's going on in language. That's the generative role. The so-called lexical rules are not relatively uninteresting add-ons to the grammar. They embody all the partial regularities of the language, and even completely productive rules or schemas can act as lexical rules. If anything is an add-on, it's the generative role of schemas. Only some schemas have it. And this really refocuses linguistic theory in a quite a new direction, I think, because it's saying we should be paying equal attention, if not more, to the non-productive patterns than to the productive ones. Okay, now for the rest of the talk, I'd like to show you some of the things we can do with the relational morphology formalism, and then at the end, talk about how this fits into the mind as a whole. So the first thing I want to talk about, I want to show you how it can do some things that are kind of awkward for traditional rules. And I want to show you how it opens up some new and interesting questions. So first case is there are a few words of English that contain something that looks like an affix, but this affix occurs only in one word. So here's some examples: laugh and laughter, hate and hatred, compare and comparison, and so on. It'd be really weird to have a word formation rule that said to form a noun from laugh, add ter. This would be a rule with one instance. That's no rule at all. Or you might say, oh, well, the affix ter is listed somehow in the lexicon, but it's equipped with a feature that says, I can only appear with laugh. Well, that's equivalent to just listing laughter. In RM, we can use a relational link to directly connect the verb laugh to the base of laughter, just like we did with pig and piggish. It's very simple. There are no schemas involved, but these word-to-word unique relations can still be captured in the theory. Now, we found ourselves always asking how many instances does it take before a schema is warranted? as opposed to these cases with one instance. And the biggest family we found was the horror family: horror, horrified, horrid, horrible, horrific, horrendous. It has 6 members. We're not sure whether there ought to be a schema for these or not. There are other cases that surely call for a schema. For example, the family of Harden and Whiten that we talked about, which has several dozen instances, or the family of construction and desertion, which has hundreds or maybe even thousands of instances. So the next case I want to talk about is something that I mentioned earlier in the talk, words that have a well-established affix, but the affix is attached to something that's not a word. Things like gorgeous, impetuous, arduous, meretricious, salacious, and so on. Thinking of these as a minor glitch in the system. Again, they appear maybe a couple of paragraphs in chapter 2 of your morphology textbook. But in fact, there are hundreds of words like this. Just with the us ending, there are about 250, I think. What's their structure? Well, let's look at, this is gorgeous. The affix OUS in phonology, pronounced us, is marked in morphosyntax as an affix with subscript 8. But the gorge part doesn't have a syntactic category because it's not a word. So the morphosyntax just has a dash there. And the meaning can't be divided into the meaning of the base plus the meaning of the affix. So the meaning doesn't have any internal links either. And I think this is just about right for what we want to say about the structure of this word. But now we need a schema that says there are a lot of these us words without a lexical base. And that's what this schema says. The semantics is extremely vague. It just says an OUS word denotes some kind of property. That's about all you can say about adjectives in general. It says the word is an adjective that ends in an affix, pronounced us, and that's all it says. So to use Steve Anderson's term, gorgeous is partly amorphous. Us is a morpheme, but gorgeous not. Another case that's really interesting is a pair of words that are related, but you can't derive either one from the other. So think about assassin and assassinate. From a morphological standpoint, you want to say assassinate is built from assassin, but from a semantic point of view, an assassin is someone who assassinates people. So assassinate is the base and assassin is the derived form. Well, that means that the direction of derivation is mixed. You can't get a single rule that derives one from the other in either direction. Well, in our formalism, we can say the meaning of assassinate is something like murder a politician. This occurs inside the semantics of assassin. The syntax of assassin is it's a noun. The syntax of assassinate is it's a noun plus an affix. The phonology of assassin is assassin, and the phonology of assassinate is that piece assassin plus the affix 8. So what we end up saying is that each one is partly motivated by the other, but it's a different part in different components. So we call this a sister relation. These are related, but they don't have a mother or more abstract form that they both inherit from. Another case, just for fun, is linguist and linguistics. Think about it. Another kind of sister relation is when we find words that are related through a base, but the base isn't a word. So a couple of cases are ambition, ambitious, contagion, contagious, and cognition, cognitive. I've color-coded this so that you can follow what happens here. The stuff in red shows the semantic relations between the two. Ambition is some kind of a desire. Ambitious means you have that kind of desire. The morphosyntax is there's a dash, ambi has no part of speech, and different affixes for the two items. The phonology has ambish or ambi, something like that, that is shared between the two words. So the stuff in green is the relation in phonology, and the stuff in blue is the affix, and the stuff in red is the semantics. The story gets even more interesting when we look at what Geert Boy has called second order schemas, what we call sister schemas. So consider pairs like pacifism, pacifist, Marxism, Marxist, and so on. The left-hand member is a name of an ideology, and the right-hand member is an adherent of that ideology. We want to say those are related the same way as ambition and ambitious are, but at the same time, there's a whole schema for the ism words and a whole schema for the ist words. So what we want to do is say there are schemas that are related to each other, and here's how we do it. We have on the left an ism schema that denotes an ideology, and on the right-hand side we have a schema that denotes an adherent of an ideology, and ends in ist. And what we say is the ideology is the same in these two schemas, and that's denoted by the Greek letter alpha in red, and the phonological base is the same in the two schemas, in the instances of the two schemas, and those are marked with the subscript beta in green. Got that? This turns out to be useful for paradigmatic relations, stem allomorphy, truncation, and inflectional classes. And what's interesting about it is it's a simple formal extension of the notation for sister words that we had for like ambition and ambitious. It's the very same formalism. So this is another reason to eliminate the lexicon grammar border, because we can use the very same formalism to get relations between words, between pairs of words, and relations between pairs of schemas. If we think a little bigger, we say, okay, you have these sister schemas in morphology. I wonder whether we have them in syntax. What would the counterpart of sister schemas be in syntax? And the answer would be, here are two constructions that are in some equivalence relationship between them, or a sister relationship. This has been sneaking into construction grammar incidentally under the term horizontal inheritance. Instead of something inheriting this way, you're inheriting sideways. Now, this turns out to be have interesting antecedents. This was actually Zelig-Harris's notion of transformations. In his 1957 paper on transformational grammar, he proposes transformations that involve establishing equivalence classes among constructions, basically. It's quite different from Chomsky's version of transformations, which derive one thing from another. And Harris covers almost the very same phenomena that Chomsky does. It's really interesting. So now we're going back to Harris and putting him, or bringing him up to date in the formalism of relational morphology. Let's see what we get. Well, here's a possible candidate. This comes from Bert Capella, who has done it in a construction grammar framework. It's the English particle alternation. It says, so the alternation between look up the answer and look the answer up. The semantics is the same, that's indicated by subscript delta. The verb is the same, that's indicated by subscript alpha. The particle is the same, subscript beta, and the direct object, the noun phrase, is the same, that's subscript gamma. The only difference in the two schemas is the relative ordering of the noun phrase and the particle. So we can think of these as sister schemas. Another case is the dative alternation. This has been discussed by Eva Zehentner and Elizabeth Traugott. Here it's the relation between give Bill a book and give a book to Bill. Back when I was a graduate student, we thought there was a transformation that changed give a book to Bill into give Bill a book by moving Bill in next to the verb and deleting to. By 1975 or so, that was debunked. You couldn't do it because there are verbs in the ditransitive construction that have to be listed that don't have a counterpart in the prepositional dative. The meanings are slightly different and so on. So you can't derive one from the other. And you have to list the verbs that allow the alternation, at least for the ditransitive. That means the schema is non-productive. But we do have sister schemas that give us the relation between these two constructions now. Another case, which I'll go through very fast, is the nominals of particle verbs. So from the particle verb X blows up, we get the noun blow up. X picks Y up, we get a pickup. If you throw something away, it's a throwaway. If you knock someone out, it's a knockout. The semantic relation in each pair is a typical nominalization pattern. But as Chomsky showed us back in 1970 in Remarks on Nominalization, in general, you can't derive nominals from verbs in general. In this case, from particle verbs. However, we can state this relationship in terms of sister schemas like this, where the syntax says here's a verb particle construction, and it's related to a morphosyntactic schema with the same verb, subscript alpha, and the same particle, subscript beta. So here we have a pair of sister schemas, one of which is phrasal syntax and one of which is morphosyntax. That's really interesting. A final case like this would be the symmetrical alternation. And again, when I was a grad student, we would start with x is similar to y and derive x and y are similar, or vice versa, I forget. And this was shown not to work, this syntactic derivation was shown not to work by, I believe, Lakoff and Peters in 1971 or so. You can't, and it turned out you can't derive either one of these forms from the other, but the generalization in terms of sister schemas is clear. I don't know how to notate this and I'm working on it, but you can see that their this lines up just like the ism-ist pairs. So now as we start going through these cases, we start asking the big question, can you account for all syntactic alternations this way? Was Harris right and Chomsky was wrong? The same issue actually arises in phonology. Can you do we do phonological alternations often in terms of sister schemas like sing-sang. Can you do phonological alternations in general that way? Big question, I don't know. But let me sum up where we've gotten from here. We've integrated the grammar and the lexicon because rules of grammar are encoded as schemas in the very same format as words, except that they contain variables. So the lexicon, or extended lexicon if you like, contains the grammar along with the words and the idioms and the collocations and the schemas for suffixes and God knows what. We've integrated the productive and non-productive patterns because productive schemas can be used both to create novel forms, that's their generative function, and to capture generalizations within the lexicon, that's their relational function. Non-productive schemas are used only in the relational function. So it's not like the productive rules and the non-productive rules are entirely different. They're intimately related. We've found that the lexicon is not just a list of junk, it's richly structured. In particular, it's full of relational links among items. It's not just a list of exceptions. And the moral we draw from that is that linguistic theory ought to be focusing on lexical relations at least as much as on the construction of novel forms. Now, this leaves many challenges for the theory, which Jenny and I alone can hardly fulfill. And I hope somebody out there will get to work on it. So the question is, can we apply the formalism of relational morphology to the full range of morphological phenomena in the languages of the world? Well, we've done some work on Dutch and German in addition to English. And the book has a few examples from other languages, particularly for things like infixation and inflectional classes. But there's lots to do. Let that truck go by. Next question is, can we develop theories of morphological processing and acquisition of morphology that answer to the very complicated and confusing experimental literature? And again, we've made some progress. That's chapter 7 in the book, of integrating the morphological theory into a story about processing and a story about acquisition. Now, I want to go on for another few minutes with what might be taken as a digression, but it's really important, I think. If we think what we've got in relational morphology, it's based on the question of what a speaker stores and in what form. That is, what is knowledge of language like? If you think about it in the bigger picture, it's therefore a theory of one domain of memory. So you might get really ambitious and say, can we extend this approach to other domains of cognition? This is a wild speculation, but what the hell? Let's try it out. So our hypothesis is that memory is memory is memory. Pretty much the same organization we'll find in every domain of memory. And the differences will lie in what kinds of units structures in these different domains are built from. So here's what we find in the structure of the lexicon that might generalize across. First of all, the lexicon is vast. There are tens of thousands of items, maybe hundreds of thousands of items if you include all the collocations and stuff. There are multiple levels of representation, semantics, syntax, phonology, that are coordinated by interface links. There's hierarchical constituent structure within items at all three levels. What we've been adding is there are relational links among items that pick out shared structure, and that regularities across items are picked out by schemas. And we find both free items like pig and bound items like ish that cannot occur on its own. So let's see how many of these properties actually are shared with other domains. First, let's look at music, which I know something about because of my work with Lerdahl back in the 80s. Think about how many tunes you know, such that if you turned on the radio, you would be able to identify the song like that in a second or two or three, but you could identify it. I think if you start counting them up, you'll get that there are thousands of them. And some of us know very large pieces of music, like 45-minute symphonies and so forth, such that you turn on the radio and you recognize it immediately. Musical cognition has linked levels of representation. Lerdahl and I propose grouping structure, metrical structure, and a tonal hierarchy, which we called a prolongational reduction. Each of these is kind of hierarchical constituent structure. And there are relational links. We've talked about relational links in across different items, but in music, there are relational links inside of pieces of music that pick out the shared structure. So if you recognize repetition or motivic relations in a tune, that's putting a relational link between them in your representation in memory. The regularities across items are picked out by schemas. And in fact, the grammar that Lerdahl and I wrote for Western tonal music really involves schemas rather than generative rules. And it encompassed things like rhythmic and melodic and harmonic patterns that are characteristic of the style. There are both free items and bound items. If you don't know music theory, this won't make much sense to you. But if you do, the dominant harmony in a dominant tonic cadence is a bound item because it can only exist in the context of its resolution. And an appoggiatura is a dissonant note that has to resolve to a consonance. And again, it can't be an appoggiatura on its own. So we conclude that music has the same sort of organization in memory at this very speculative level. I think there's not a lot of time left, so I'm just going to list the other ones that Jenny and I have thought about. One of them is knowledge of objects, for which you can identify tens of thousands of object types, not necessarily by words. They have multiple linked levels of representation, how it looks, how it smells, how it moves, how you use it, and so on. And just let me jump to free items and bound items. So chairs are free. They can be moving around from place to place. Handles are bound. They only work when they're a handle of something. Stripes and holes only make sense if there's stripes on something and holes in something. So those are like bound items. Another case would be geography and spatial layout. How do you find your way around? How much knowledge does that entail? And what's that knowledge like? And the last one I want to mention is social knowledge, where there's a vast lexicon about how many people you know, what you know about them, how many rules of proper behavior you know, and what kinds of representations do you need for this at all. So the conclusion is, at least at this very impressionistic level, many properties of lexical knowledge are replicated in other domains of knowledge. They differ, though, in what their items are made out of. So in language, it's phonological and syntactic units. In music, it's sequence of pitches with duration. In object knowledge and geographical knowledge, it's visual or spatial units. In social knowledge, it's persons and their affiliations and their behavior and their norms of behavior, however those manage to be coded. So to end up, what we like about this approach of relational morphology is that, unlike other morphological theories, it's not only great at talking about morphology, it's leading us to look for integration of morphology with syntax, of all the pieces of language with each other, and the integration of language with the rest of the mind. And that's what you want eventually for a theory, I think, an integration of all kinds of phenomena. And that helps us think we're on the right track. So thank you very much.
Thank you so much, Professor Jackendoff. Now I'm gonna relay some questions from the audience, right? So one of them, asked by Janaína, is, would like the same sort of schema carry over to syntax? I think the answer is yes, but then she like elaborates, asking like how, like, would, for instance, long distance dependencies like parasitic gaps be accounted for schemas of the same kind?
Yeah, good question. I mean, I don't know about parasitic gaps because I don't have the intuitions for them strongly enough to actually understand what people are writing. But long distance dependencies, I think you want to say the schema says there's a WH phrase at the front of some clause, and there's a gap somewhere in the clause, and the gap is linked by a relational link, internal relational link to the WH phrase. And you can duplicate that for all the different kinds of long distance constructions. And then you can have a higher order schema that is the equivalent of, you know, a bar movement that says there's a gap somewhere down inside a syntactic structure that's related to a designated element at the front of designated form. Actually, you have to know what the appropriate signature of the long distance construction is. Is it a WH plus declarative, or a WH plus infinitive, or a comparative, and so on and so forth. So I think it lends itself to a schema formulation, and Culicover and I in simpler syntax got close to that. We didn't make it all the way, but we were on the track of doing it that way. So take a look at simpler syntax and see what we did there.
Okay, so another question by Pablo and Mariana is, assuming that words and grammatical schemas are of the same nature, at least in their representations, would you consider that they are stored in exactly the same way in long-term memory?
Why not? We don't know how anything is really stored in long-term memory. They'll say, right, I mean, we learned from fMRI that if you're doing this task, this lights up, and if you're doing this other task, this lights up, and this area looks like it's used for language primarily, but it overlaps, its use is overlapping with all kinds of other functions as well. And even if we know where it's taking place in the brain, we don't know how it's taking place in the brain. How does the neural wiring support even something as simple as a phoneme, right? What's the difference between a P and a B in the brain? We don't know very much about that. So whether it's, the schemas could be stored in the same place as the words, but the operation of putting them together online could be in a different place. I mean, there are all sorts of possibilities, but I think we don't know enough about the neural computation to answer it yet. I've been saying that for 50 years. And we've learned so much more from brain imaging of various sorts, but I think we're not close to the basic issue yet. That will offend neuroscience people, I'm sure.
Okay, so another question by Eduardo is, how are schemas acquired? Are there any of them that are innate? And also, relatedly, I guess, what is the role of frequency in the acquisition in this field?
Okay, that's a really long story, and I couldn't put it into this talk, but it's in chapter 7 of the book. Here's the basic idea that acquisition, first of all, we're taking for granted word acquisition, which is really, really hard. That's what, vast amounts of literature has dealt with. But what you have to do is notice that two things are alike in some respect. And you have to set up relational links that say these are related to each other and they support each other. As you get more items that have the same relational links, you might say, okay, is this sufficient to have a schema? And if you want to build a schema, what you're doing is taking the parts that are the same across all the items in this multiple sister relationship, and you're putting that directly into the schema, and the places where they're different, you're putting variables into the schema. And now the question is this going to be a productive or non-productive schema? And I think you start by assuming it's non-productive. You learn more and more instances. As you learn more instances, somehow you get evidence that this is productive, but I don't know what the evidence is. You might say it's frequency, but frequency plays an interesting role in our story because there's no way, we don't think the brain is counting, but we think frequency is a proxy for something like resting activation in the brain or lexical strength. So high frequency items are easier to activate, and they activate more strongly and maybe quicker, and they prime other things around them more easily and so forth. But that's not because there are more instances of them. Each time you hear an instance, it boosts the resting activation. It's the resting activation that's doing the work. I don't know if that answers the question. You'll have to ask the interlocutor.
Right. Yeah. I guess related to that, I'm going to sneak in a question of mine there, which is, so frequency has a role, like through maybe as a proxy for resting activation, and that leads, I guess, to the question of how to decide when, it gets to the general question of how to decide when a pattern is productive or not, and especially in these cases where you have a very frequent rule that nevertheless is not productive, like meant affixation, like meant nominalizations in English, right? Yeah. And on the other hand, you also have some patterns that are not as frequent, but still are very productive, like German plurals, right? As with S German plurals.
My favorite example of that is the construction in English. I'm coffeed out. I don't know if you're familiar with this. Yeah. There you go. You're being coffeed out right now.
Yeah.
You can put any noun in there. You can put a proper name. You can put a verb in there. And you hear this maybe 2 or 3 times a year in spontaneous conversation. And you don't even notice it if you're not a linguist. So you can be, I've had people say, I'm historied out, I'm Olympic'd out, all kinds of crazy things. But that's because I'm a linguist and I remember them and write them down. So it's productive, but hugely infrequent. So what's the evidence that you have that it's productive? How do you learn that it's productive? I don't know. And I keep asking people and nobody has any idea. So we'll leave it at that for now. That's a puzzle for somebody to work out someday.
All right. Another question, I think, related to acquisition, is a question by Mariana, and she asks how to account for the fact that words are added to the lexicon all the time, but grammatical rules are not, when you're considering that they have basically the same representation.
There are just a lot more words than syntactic constructions, but there are more syntactic constructions than you think. Also, if you look at the work in construction grammar, they find all kinds of strange things and all kinds of very prosaic things, like, they'll have the verb particle construction, the ditransitive construction, the caused motion construction, all these kinds of things, some of which, they think they all relate to semantics. I'm not sure of that. I don't think the particle alternation has any effect on semantics. But that's a minor difference between the theories, I think. I've lost my train of thought. I'm sorry. So why are there more words? Well, constructions have to make use of words, right? And they're just ways of putting words together. And what would it mean to have a language that had more constructions than words? It'd be really a funny language. I don't know. I mean, it's an interesting question.
Right. Okay. So another question related to productivity, I guess more fundamental, is how exactly the productivity of a schema is marked in the variables, and is it of some sort of feature? And if that's the case, is it binary, productive, non-productive, or is it a gradient feature?
Yeah, good. Something that we've thought about quite a lot, actually. rather than saying the whole schema as a whole is productive or non-productive, we do want to say it's a function of the variable that is productive or non-productive. So that allows you the possibility of schemas that have one productive variable and one non-productive variable. And that's true, for example, in the NPN construction, where the choice of preposition is non-productive. There's 6 of them. But the choice of noun is totally productive. You can have day after day, week after week, student after student, term paper after term paper, ad infinitum. So we want to say that the noun variable in that construction is productive, but the preposition is non-productive. How is that marked? Well, the simplest would be to say it's a binary feature. Some people would say, well, it's a gradient. You know, how reluctant are you to coin new terms? We're sort of sitting on the fence about that. We're not too sure. It doesn't matter to our overall story too much. But there are things that are fashionable that go productive for a very short time, for example. So a case in Dutch that Jenny observed was there was a while when people were using "fee" as a suffix that meant derived from selfie, that meant taking a picture of yourself. So if you're riding a bike, the word for bike is fiets. The fiets fee is a photo of yourself on a bike. If you're viewing a panorama, it's a panorama fee, picture of yourself viewing a panorama. If you're voting, that's stemmen, I think. Then a picture of yourself in the voting booth is a stem fee. And there's a website full of these things. There were dozens and dozens of them coming along for a while, and it seems to have sort of, the faucet has been turned off. They're much rarer now. So this is something that was rather productive for a brief period of time for fashion and then stopped. These are sociological things that we have no grasp of.
I think that's a good segue to Maria Barda's question, which is how schemas relate to language change. For instance, for example, in the case of a productive schema becoming a non-productive over time, right? And presumably that in this case, in the Dutch case, that happened across the lifespan of individuals, right?
Yeah, it happened across 2 years, right, or something. Honestly, we have had very little to say about diachronic linguistics language change. I mean, we can say, here's the difference in the schemas, and here's the differences in the lexicon, the relational links at stage 1, and here they are at stage 2, so here's what's changed. But as for what's driving the change, I think we're in the same situation as anybody else to say what causes grammar to change in a community over time.
So there's also a question about the evidence for non-productive relational schemas. And the question is how could one tell that a non-productive relational schema has become instantiated in some individuals' mental lexicon, right? So do you believe that there conceptually or empirically there's a way to distinguish between two people who both know the words embolden and enlighten, but only one of them has the relevant non-productive relational schema?
That's interesting because it turns out it doesn't matter too much. You could say this individual has the relations, and you might be able to find that experimentally with priming or something like that. I don't know. And this individual has a different regularity or hasn't picked out the regularity. And we expect there are individual differences in how acute people unconsciously are at picking out similarities. And that might account. So some people, at least under some circumstances, will detect a regularity where others will not. So for example, I had a student who suddenly had the insight that torrential is related to torrent. You know, there's a big insight. Or actually my granddaughter, learning the word owner, there was this sort of epiphany as she learned it. She asked her mother, what's owner? And she thought owner of the dog. And she thought it might be like the hair of the dog or the collar on the dog. And her mother said, well, who does it belong to? And then my granddaughter said, oh, own. So she's making the connection once she knows what the meaning is, okay? So there are all these individual little things that can happen consciously or unconsciously. We can make anecdotes out of the conscious ones, but we'll leave it up to the language acquisition experts to do the unconscious ones, I guess.
Right. Okay, so Giuseppe asks, so like assuming that the treatment of alternations in terms of sister schemas requires independent storage of each variant, like for instance, a passive variant and an active variant of a sentence, how does this account for the productive nature of some of these syntactic alternations?
Wait, can you start with the beginning of this again? Something didn't register.
Right. So he's asking about the treatment of some of alternations in terms of sister schemas. Right?
Mm-hmm.
So the idea is that if you have a sister schema, then you would need independent storage of each variant. So first question is that true? And then if that's true, how does this account for the productive nature of some of these alternations?
No, I think, let's see, you would have to come up with a schema for each variant. Mm-hmm. And that might be independently or it might be simultaneously, I don't know. Mm-hmm. And you have to have relational links between the two schemas to say they're equivalent. I think that's all you would need to do. And now if and it may be that one of them is productive and the other is not. That's even a possibility. I think that's true with the dative alternation, example, where the choice of verb in the ditransitive is limited in certain ways. There are a couple of different families actually in the ditransitive relation. I wrote about this in Semantic Structures, and Pinker wrote about it in The Language Instinct, I think, something of his. But in terms of the output, what somebody will be able to do, well, how do I want to put this? I think it lands you a little bit in Tomasello land. That is, you have to learn the individual items in order to find the regularity. The regularity doesn't come for free. And I think that's right. You have to say what information is available to the child. Where I disagree with Tomasello would be he would say, well, who needs any universal grammar? Who needs any innateness to bring off this learning? It's all general purpose stuff. And I don't think that's the case. So you have to be very careful in making those arguments.
Yeah, I guess related to that, Andrea asks, what's your view of a radical exemplar theory of morphosyntax where each schema is not an abstraction, but a cluster of real stored exemplars?
I don't know how to formalize that. And I don't know how you use that to combinatorially, how you form a sentence out of some collection of clouds. And the idea that you're just collecting examples seems kind of perverse because it doesn't leave any room for generalizations. And surely there are generalizations in language. You can say, well, there's some variation around the corners of every rule. They all leak a little bit. But again, this formalism allows us to say that because we can say let's say, going back to Piggish, not everything is part of the regularity. There's some part that you have to memorize and learn about this word that isn't coming from the elements that it's composed of. I don't know if that helps.
I have a shameless plug to Andrea. Like, this is my dissertation's question. So,
okay.
Another question is, if schemas are all there is to knowledge of language, how do you account for the fact that certain properties tend to cluster together across different languages in a macro-parametric way?
Well, first of all, schemas aren't all there is to language, they're words. Although words have schematic properties too. If you think about selectional restrictions and subcategorization frames, those are variables. So a transitive verb says, I have to appear with a noun phrase after me. or a trace of a noun phrase after me. I don't care what that noun phrase is. That's up to you. So it's a variable inside the lexical entry of a word. And so even words can be rule-like in that respect. What about clustering together of patterns cross-linguistically? Are you thinking of regional patterns, like Sprachbund? Or you're thinking of?
That's a good question for Giuseppe asked this question, but
Can't find them.
yeah.
Okay.
So.
I think it's the same problem as everybody else has in that respect. We just want to say, in what respects are the grammars similar across these languages, or some feature of the grammar is similar across languages. Now, one of the nice things is we're not locked into saying everything's done with parameters or micro-parameters, they're innate. The schemas are doing that work, and we're assuming the schemas are learned. They're learned on the basis of knowing what kinds of possible things there are in schemas. But the ways of putting them together and learning from them are probably cross-domain. That was the gist of my remarks at the end.
Yeah, so I just got some clarification. So the asker was thinking about things like branching order, right? So if you have a head parameter, then you can predict the order of all kinds of complements in a language and so on.
Right. Well, you can have a schema that's really open, and that says I'm productive, and it says here's where my head goes, and it can even extend. You can even apply X-bar theory to it and say I don't care what category you are, that here's where the head of this category goes in relation to the phrase that it's the head of. And here's its position in the phrase.
So another question coming from Anna is, how do schemas relate to the problem of compositionality, especially with non-productive schemas and the idea of storing idioms like break a leg?
Can you read the question again, please?
Sure, yeah. I guess there are two, So the general question is, how do schemas relate to the question of compositionality?
Well, compositionality.
Which is very broad, right?
Are you talking about semantic compositionality?
Exactly, yeah.
Yeah, well, I mean, what's important is, and I've argued this in semantic structures and in foundations of language, that the language is not purely compositional in the Phragian sense, that the meanings of sentences are built up from the meanings of the words and other stuff. And the other stuff includes coercions, it includes, so things like the ham sandwich wants a cup of coffee, where ham sandwich means the guy with the ham sandwich, or the interpretation of ellipsis, where where you can't find a syntactic composition that expresses what the elided piece is. There are all kinds of other phenomena that are not purely compositional, but you can state them as schemas in terms of saying, oh, here's a nice example. So take the construction, that gem of a theory, or that bastard of a professor, that kind of thing, okay? Now, if you think about this, the semantics is, this theory is a gem, which is a gem. That's really the meaning of it. Or this professor who is a bastard, right? So what's happened is that the syntactic headship is the opposite of the semantic headship. And you can state that as a schema, as a correspondence rule that gives you a kind of interface link between the syntactic form of this and the semantic interpretation. It's non-compositional in the sense that you can't get that reading out of the usual way of composing, two nouns, let's say, and say gem and theory. So there's all kinds of flexibility there that you don't have in a strictly compositional theory of the Phragian or formal semantic sort.
Another broad question, which I guess is, what would you have to say about like claims that the theory is very unconstrained? So the question is like literally is like, are not schemas too powerful? So in that they would be a theoretical problem in Popper's sense? That's.
I don't like those kind of arguments put that way. For example, our theory of syntax has no movement. It has almost no empty categories, only possibly for the trace of A-bar extraction. It's highly constrained, and there are not many pieces. I mean, how do I want to put this? What kind of, it doesn't rule out grammars that could be ruled out on other grounds. Let's say a language with 102 vowels or something like that. But you can rule those out on performance grounds. And that's probably true of a lot of other things too. I don't know what's constrained about the minimalist program. If you can make up functional categories to suit yourself anytime you want, and you can make up micro parameters to come out any way you want. And typically what I see in these talks that I go to that invoke the minimalist machinery that say, well, this moves here and this moves here and this can't move here and so on. You say, how do you get the grammar to say that? And they'll just say it's a parameter. You say, well, how did you learn to set that parameter? I mean, it doesn't answer any of the deep questions. And at least we're attempting to answer the acquisition question and the processing question. So on the other hand, you don't want the theory to be so constrained that you can't do everything that you need to do, right? So you have to be able to deal with these strange constructions like a gem of a theory and these strange phonological things like sing and sang. And you need a theory that's powerful enough to do all those things. So I would push back against the saying it's not, it's too powerful.
Okay, so I guess there's at least one more question, which is, so this is actually my question. So what do we get from assuming that words that don't have a lexical stem, some of them like compassion, contain an affix? I assume that an alternative would be to assume that these words have just remained in the language with a meaning that is related to complex words that contain that affix. And if I understand the proposal, then the only component that is added compared to that alternative, the only component that is added to the schema is the morphological one, is the information that there is one affix there. So, but then what do we gain from that?
Well, I mean, the fact that it is a remnant of an old form is not something that's available to the language learner. We can only say, what did the language learner get? There's no evidence whether a word is old or new, right? So there's no problem in dealing with that issue within at least the scope of the theory. The history of the word might be interesting, but it's not part of the speaker's knowledge. Right. The fact that it's like the second part of the question is, again.
Yeah, yeah. The question is like, what do we gain from assuming that that a word like compassion has an affix?
Well, I don't know. I think that's just kind of obvious, isn't it? I mean, I don't know. Maybe it's not. I mean, maybe we have to have an argument about that. But there are hundreds of, let's say, when I looked at the OUS words, which I looked at in some detail, there are about 200 of them without a lexical base and about 400 more with a lexical base. But in terms of the way they enter into the syntax, they're identical. They just look like adjectives. But in terms of what we don't know is whether there hasn't been any experimental work on these kinds of items, and it would be interesting to see. I mean, we would predict that, let's say, scrumptious is, other things being equal, easier to process than crocodile. because scrumptious has an affix that we know, and crocodile is completely morphologically inert, let's say. But scrumptious would be harder than glorious because it has this unknown. Its base is not motivated by something else. I would love to see somebody do some experiments on it. It's really tough to work up the stimuli for such a thing because you have to control for all kinds of things, including frequency, which makes it not very easy.
Right. And in that case, sorry.
No, I'm done.
Would you consider that like the same sort of schema would operate in like for phonous themes, like glitter, glisten, glow, gleam, right?
Yes, indeed. So that's something that where the gl is not a morpheme, it's not a prefix, it's not a suffix. It's just this piece of phonological junk that happens to be connected loosely with something about sparkling lights or something like that.
Right.
So yeah, this is a possibility. We haven't spent a lot of time thinking about it, but it's certainly open. Oh, we have examples that are a little like this. Things like a million, billion, trillion, quadrillion, and so forth. Illion is not a suffix, and b is not a prefix. So we're just putting together this form, and if it ends in illion, it means some power of 10 to the third or something like that. And the pieces individually are meaningless. It doesn't have any morphemes in it, but it has phonological segments that are somehow meaningful or another. So that's a lot like the phonous themes.
Right. So, or bazillion, right?
Yeah, that's right. So we can coin things like bazillion and cajillion and things like that, using the illion, which is not a suffix and not exactly a stem either.
Right. Okay, yeah, so I don't see any more questions from the audience. So, I mean, thank you so much, Professor Jackendoff, for your great talk. And thanks to the audience for your participation and for all your questions. And I also take this moment to stress the importance of joining the Brazilian Linguistics Association as a way of strengthening our field and making other events like this possible. And keep watching and sharing the other talks in this series. And finally, a special shout out to my fellow Black linguists in Brazil with a plea to the Brazilian linguistics community to seriously consider and ideally do something about the fact that there are so few Black and indigenous linguists among us. Now I hand you over to Professor Jackendoff in case he has any closing words, and bye.
Bye. Just wanted to say thanks again. I hope some people out there, however many or few there are, got something out of the talk. And if you have questions, further questions, or want to work on something, please get in touch with me. Thank you. Bye-bye.